All right. So for these problems, we are going to focus on volume. And these are volumes of prisms. So what makes a prism? A prism is a figure that has a front and a back, or a top and a bottom, or front side, back side, however you want to think about it. But you have a figure that's the same on the front and the back, or the top and the bottom, is what I told my students to focus on. So whenever you're finding a volume is always going to be the base shape area times the distance between the two bases. My student teacher came up with that. I thought it was genius. So I'm stealing it from her, but it's the distance between the two bases. A lot of the times you call it the height of your figure, but you have to be careful because if you're doing like anything with like triangles or trapezoids, you need the height for the base shape, and sometimes it's not called the height. But it will always be the distance between the two base shapes. Okay? So, in this case, our base shape is going to be this blue rectangle. So what I'm going to do is, I'm going to draw this blue rectangle because this is my base shape. And what I need is the area. And because it's a rectangle, we're going to do length times width. So the length of this is going to be 7.4, and the width is going to be 3.3. Now the height of my figure, I already know. So my base shape is going to be a rectangle. And the area of a rectangle is length times width. So this base area now becomes length times width, and my height just stays the height. But we already know what the height is. So my base shape, we're going to say is a rectangle. And this is going to be height. So we're going to do length times width times height. So my length is going to be 7.4. My width is going to be 3.3, and then 17.3 is going to be my height. So I have 7.4 times 3.3 times 17.3. 422.46. 422.46, but the 6 behind it makes a 7, so 47. Because this number, if it's 5 or higher, rounds that one up 1. Otherwise, it just would have stayed the same. So this becomes my volume for this box almost. It's kind of like a, one of those clothing boxes you get on Christmas that's coming up. That long elongated box. It's not very tall. It's kind of wide and it's really long to fit shirts and stuff in. So this becomes our volume. And every volume that's a prism is just the base area times the height. Now what's going to change, you're going to see, is what is my base shape. My base shape for this is not a rectangle. My base shape for this is going to be a triangle. Now, this time our distance from base shape to base shape is going to be a W. So that's what we do, the base area times W this time. And because we have a triangle, that's going to be 1/2 base times height. So that's what's going to go in here. So we have a base area times a width this time. Our base area is going to be 1/2 base times height, and then times it by our width. So our width is going to be 11.4. That's always going to be the distance from the two base shapes. Okay? Now, if I draw my triangle, there's a height that comes down here. That's the easy one to assess. And that's 2.2. Okay? That's your height of your triangle. So 2.2 is the height. We still have the 1/2. Now we just need to fill in the base. But the base, sometimes people get confused. But when you draw the height, this makes a 90-degree angle with the floor. And this floor is the base of your triangle, okay? Now, because it's the only numbers in the picture, yeah, that's kind of obvious. But when they start adding extra information that you might not need, maybe they tell you this is 9.2, this one of this angles, and then this one's something different. What you need to understand is you only need the base and the height for the triangle, okay? So this becomes an 8, and then we do all of this, multiply it together. So half of 8 is 4, 4 times 2.2 times 11.4. We do that, we get 100.32 as our final solution. Okay. So you can see surface area takes a little bit longer because you have to draw that net figure and calculate all that stuff. Where with volume, it's a little bit, I don't say more simplistic, but you don't have to put so many things together. All right, so our base shape, our top and our bottom are both a circle. So a circle equals pi radius squared, okay? And then, once again, going back to what is in between the two base shapes, that's a height this time. So that's what's going to go on the second one. And then we can put pi r squared here. Okay? So the volume equals the base area times the height for this problem. Our base is going to be pi r squared times the height. And then we already know what the height is. The height is 23.7. We have pi, and then we have some number squared. And that radius is going to be 8.3. So what we want to do first, actually, is do the 8.3 squared first. So we're going to do 8.3 times 8.3, and we're going to get 68.89. So we have pi. We have 68.89. And then 23.7. Now, once we multiply all those together, so we're going to do 68.89 times pi times 23.7. And we're going to get 5,129.3. 5,129.3 volume. Okay. So we want to add a little justification. This is the volume formula for any prism. Then we substitute in our circle, and we substitute in our values, and our values being R equals 8.3, H equals 23.7. That's given information because the picture tells us that. Simplify exponent. And then multiply. And once we do that, we get our final solution. And was that 3? It was. Look at how fast that goes. So yeah, there's our volume stuff. Okay, Kat, what's going on? Well, what can I help you with? So when you say can you teach me? I need to know this. So what can I help you with? Where are you starting? And I need to figure out settings for the live chat. Oh, no, I don't want that. Please, I need to know this. All right, so let me help you. Where are you doing volume or are you doing surface area? Do you know? Because we did a little surface area before. Okay. Because we did a little surface area here. Let me keep commenting. I'm gonna try and open up something over here that I think can help you out as well. Because we literally did this in my class today. Oh shoot, whatever. Drive and then pull out geometry. And first semester, 4 lessons. Volume cheat sheet. Okay, so we did this. No, it won't go on there. Okay, we did this today. I have a big volume for tomorrow. Okay, so here's what we're gonna look at, and I did this with my students today, so you can follow right along. Let me first screenshot this out and then pull it over here. Okay. All right. So here are the first 3 prisms, and we'll get to the other ones in a minute. But here's the first 3 prisms. So when we talk about, and we talked about this at the beginning, a prism is something that has a front face and a back face. Okay. If it doesn't have a front face and a back face, you're probably on one of these 3 figures, okay? And we'll talk about those later, but for right now, we're going to stick with the prisms because the prisms are the first set, and then these 3 are kind of your exceptions to the rule. All right, so on this, we have a square prism. So what you need to understand is that this right here is a square. And the reason I know it's a square is because this and this are the same letter, which means they're the same length. So no sides. No sides, question mark? What do you mean, no sides? So we have a square here. All right. So I'm going to say my base shape is going to be a square. Okay. Oh, I bet. No worries. So we have a square here. We have a square in the front and a square in the back. Okay. So when we look at just a square has the same side length all the way around. And if we want to find the area of a square, we would do it just like a rectangle. We would do length times width. But because they're the same, if I put any number here, let's put a 3 here. If I do length times width, I'm really doing 3 times 3, okay? Which would just give me 9. So when we do the area of a square, my base shape, it's just going to be a side length times a side length. Sometimes they will represent that with s squared instead of s times s. But it's the same thing, so don't get caught up on that. Like, don't get too confused on that. Now, when we do a volume, A volume is always going to be the base area. So that BA, that stands for base area. And as you can see, we started with a square. We're going to move to a rectangle, then a triangle. We'll get to all the shapes, but your base area is your figure. So we're going to do the base area, and then the next piece is the distance between the two faces. So when we look at this, this is the distance between the front face and then the back face. And you got to be careful because sometimes it could be a top and a bottom. So you just have to know that you have two of the same shape either on the front and the back end or the top and the bottom end. All right. We look at these, there's only one shape, and then there's this crazy thing. Okay. So a prism has the same shape on the front and the back. All right. So when we look at that, we're going to have the base shape be a square. So that's side squared. And then the distance between the two faces is going to be an H. So that's going to be an H. So for the volume for any square prism is going to be S times H. And then you could plug your numbers in if you knew what the numbers were. Otherwise, this is going to work for every single one of them, depending on what these numbers are that they give you. How does the square feel? Square okay? Okay. All right. So then let's look at the next one. The next one is going to be a rectangle. All right. So when we look at a rectangle, first off, let's just draw a rectangle over here. So a rectangle does not have the same length all the way around. It's got a length and then it's got a width, and they're usually two different sizes. If they're not, then it goes back up to the square. So we want to focus on this. So when we look at a rectangle, and you can kind of see I highlighted it in blue. You can see this front face right here is going to be this front face right here. Okay? So in order to find that area, so in order to find this area of a rectangle, we're going to do length times width. And this is our base area. So inside of this, we're going to do length times width. Now the other value comes from the distance between the two faces. So the two highlighted faces, your base shapes, the distance between that is H. So that's what's going to go on this line and that line. And then your volume just becomes length times width times height. Which a lot of them would tell you, if you're looking at a box, that's how you find the volume of a box. Yeah, well, that's all well and good, but if you know why you're doing it because of that, it makes a little bit more sense. So you take the area of the front-facing shape, and then you times it by the distance between the two faces, which ends up becoming that H value. Now, with the triangle, though, you have to be careful because there's an H you need to calculate the triangle. So in a triangle, you need this height to calculate what a triangle is. So this can't be height because you need the height for the triangle. So they might change the letter on you, but what you need to know is the distance between the two faces, whatever it is, goes on the back end. Okay? Now we have a triangle. And to find the area of a triangle, we're going to do 1/2 base times height. Now we have the height, but which one of these three sides is the triangle? And the one that it is always the one that the 90-degree angle is on. So this becomes the base of our triangle. Okay? So then this is one. Ooh, come on now. Just a little light, small. Now you're not going to write anymore? Like, come on. What? Okay, we're just going to do that today, aren't we? Okay, So we have 1/2 base times height. So our volume for this whole figure is going to be 1/2 base times height times width. Nah, just give them time. Just give them time. And I'm telling you, what's going to benefit you the most, even when you're in class with your teacher, ask questions. Ask any and all questions. Like, just keep asking questions. Be that person that, I want to be the annoying one because I want to know what's going on. And if I don't ask questions, I got no clue. All right? So, trust me, I don't mind answering questions. What I don't like is answering the same question 5 times in a row because people aren't listening or paying attention. But if I know you're paying attention and you're asking questions, man, I'm all about it. Let me help you. So put that electronic device away, get focused up, good to go. All right, so we have the square, the rectangle, the triangle. How are you feeling so far? What questions could you have? Or what questions could somebody else have? Don't be afraid or hesitate to ask those either. All right, so let's get that out. And we're going to shift this over. And now we're going to talk about a trapezoidal prism and a cylinder. Okay. So for the trapezoidal prism, we are looking at a trapezoid. Okay? So for a trapezoid, if we were to build it, God, come on. Ugh, that's an ugly one. But base 1, base 2, and we get a height for this one. Okay, so in between are, let me change it to blue. In between our two faces, that becomes the number that gets multiplied, or the value that gets multiplied by the base area. So the base area is a trapezoid. So we don't want to focus on the trapezoid, but the distance between those is my W. Okay, so that's what's going to go in there. Now, tricky part is not a lot of times, I guess geometry specifically use it, but you don't use the trapezoid formula as much as you should. So maybe you don't have that one memorized. But what you do want to start working on is the more you write it, the more you remember it. But you actually have 1/2 and then in parentheses base 1 plus base 2 and then times it by the height. So we're going to do 1/2. I'm going to try and squeeze it in. It's base 2 times the height. It's ugly. But let me rewrite it. 1/2 and we're going to do base 1 plus base 2 and then we're going to multiply it by the height. And then we're going to multiply it by the distance between the two faces. Need help with that. Okay. So when we look at this, we have, in trapezoids, there's something special. And what you notice in a trapezoid, and we can call this a trapezoid as well. What you're going to notice is that two of your sides run parallel with each other. And anytime you have parallel sides, you should see 2 arrows. But these are your parallel sides. Anytime you have a parallel side, that's your base 1, your base 2. I always make the smaller one base 1. You don't have to. It's not going to make any difference. What I tell my students is if you take 2 plus 3 and you take 3 plus 2, either way you're going to get 5. So as long as you do your math correctly and adding these things together, it shouldn't matter which one you do, base 1 or base 2. So don't get hung up on that. But what you do need to know is make sure that the 2 lines that are parallel with each other are your base numbers. So when you look at your bases, base 1 and base 2, they have to be the ones running parallel to each other. Okay? So once you get that parallel situation going, you know what base 1 and base 2 are. Another cheat is usually if you see a height, there should be a 90-degree angle coming off this. Now, sometimes there is, sometimes there isn't, but there really should be a 90-degree angle coming off your picture to represent the height. Okay? Please, if they give you like the diagonal, please train your brain to ignore that. It's just extra information that's not valid for this specific situation. Excellent. Oh, good job today. That's sweet. Did you do volume today or did you do like surface area today? Do you know? All right. So last prism that we're going to talk about is a cylinder. So we have a circle for the top and bottom. So our circle's up here. So when we draw our circle, and don't judge. Ooh, that's not bad. That's not bad. Freehand on a computer screen? Come on. You got to give me props for that. All right. So for a circle, you got to find the area of a circle. And your area is going to be pi times radius squared. The radius is just anywhere on the outside of your circle to the center. Because as you rotate around, this distance doesn't change. The pencil from the center is the same distance all the way around. So that shouldn't change as you go around. So this should stay the same. And then once again, the distance between the two faces, they're going to use an h this time. So we're going to do h. Now my base area is a circle. So we're going to do pi r squared. And then we write the volume. We're going to do pi r squared times h. Oh, Kat, thank you. I appreciate it. Appreciate that like. So these are our prisms. Now, what happens is we have one other category that I throw them in is the outsiders. So we did all the prisms. Now we need to kind of focus up on these other special cases that you have when it comes to volume. Oh, shit. Oh, sorry. Kat, follow. Oh, man, Kat, you're hooking me up today. I appreciate all of that. All right, so there are 3 types of situations. 2 of them get funneled into one category, okay? The other one is on an island all by itself. The sphere is on an island all by itself. And I wish I had something to be like, oh, this is so easy to remember. It really isn't. However, I will tell you on the SAT and ACT, they give you a formula sheet. And let me show you. So let's do SAT formula sheet. This is what it looks like. So right here you can see 4/3 pi r cubed. They are not trying to trick you. They just want to make sure you know how to use these formulas. So even if you don't have it memorized, I promise you on the SAT, they will give it to you. ACT, that's not an ACT formula sheet. Can't even see that. Where's the ACT formula sheet? I know the ACT is a little different. I don't think that one's it. I'm 90% positive. Yeah, no, they're not giving that. See, sometimes you got to weed through the stuff. I just know what it looks like on the SAT because we give it in Michigan. Is it like this? This is usually your standard sheet that you get. But as you can see, the formula is there. If you don't get the formulas for your test, this might be... There is a little... Oh, did I just close? Tell me I did. Okay, I didn't screw up. All right. What grade do you teach? I teach high school. I need it for tomorrow at the end of the day. I teach high school. I'm a high school geometry teacher actually right now. I've taught AP Calc. I've taught them all. I've taught algebra, pre-algebra, algebra 2, trig, stats. Not stat. I teach sections of stats. I've never taught a stat class, but I've taught AP Calculus AB. You're good at it. Thank you. I tried. This is my 19th year teaching, so I have been around the block for a hot minute. So, but here's one thing to think about with the sphere. You have a 3-dimensional figure. Like we have an X, we've got an Y, and we've got the Z. Like we're trying to get all of the different dimensions in there. So the reason that this is a third is because of that third dimension. So if you remember that to tag on with the sphere, that will help you. And then these are both 1/3, and we're going to talk about the 1/3. So if you can remember 4/3, that kind of gets added on to the 1/3. You're almost there. But remember, what's our base shape? Remember, what's our base shape? Our base shape's a circle. So what's the equation for a circle? Why this is being so testy for me today. The pen just doesn't like me. It doesn't like me. But remember, what's the area? Isn't it pi r squared? And didn't we normally multiply it by some height, which is a radius as well if you go in this direction? So it kind of makes sense that it's pi r cubed because you're doing the area times it by the height, which is another radius, to create this. And then to get the sphere look, we need the 4/3. Okay? So if you break it down that way, that could be a little helpful to get that formula if it's not given to you. One thing I might do is put sphere on the front of the flashcard, put this volume equation on the back, and just test yourself. So it just kind of depends on that. Now, what you need to notice about these other two is they come to a point. Anytime they come to a point, boom, you're adding that 1/3 on. Okay? So don't get hung up on that. And then every time you're going to multiply it by a height. You're going to multiply it by a height. And the reason is we could continue this straight up. Draw a cylinder, right? Couldn't we draw a cylinder? That's a terrible looking cylinder. But you're getting the idea. And what we did is we shaved off a lot of the can. We shaved off all that can. So that all we're left with is this. So we only have 1/3 of our cylinder. Well, think about it. What equation did we use for the cylinder? Let's go back here. Didn't we do pi r squared times it by the height, right? To get our cylinder? Well, it's the same formula, only we're taking 1/3 of it because we shaved off 2/3 of it. When you think of that ice cream cone, that's what's put in the cylinder, but everything else around it's gone. So we only have 1/3 of our cylinder actually left. So if we look at this picture, think about it from this standpoint. What if I were to take this point and start to do this with it? See that? And then we got the center here, and this comes straight up. So if we look at that shape and you shave off everything else that's around it, you are taking 2/3 of your shape off. That's fantastic, man. I'm hoping for it. That's awesome. So kind of focus your energy on that in that thought process, especially when you're coming to these special cases. And the same thing goes for the pyramid. Once again, what's my base shape? Isn't it a rectangle? And don't you find the area of a rectangle by doing the length times the width? Like we just do length times width, and that's how we get the area of our rectangle. And then we would times it by our distance between the two faces, but there's no face up here. It just comes up to a point. So once again, we're shaving off 2/3 of our box that makes it a pyramid, okay? But it's still the same idea of take your base shape and then times it by the distance between the two faces, only you don't have two faces this time. That's why you need the 1/3 to get it to go to that point. So anytime you're going to a point, your brain needs to think of 1/3 and then just create a cylinder off of that. Or create a box off of that. Or to create a prism off of that. So, I don't know. I hope that helps you. We did a lot today. I got a lot of bang from my buck today. So we started off with surface areas. Over here, we did the surface areas. Then we did the volumes. And then we actually went through the basics. So, yeah, let me, before I get off, I do have in my Twitch link, I do have a link to it's called Math Dragon Tutoring. It's kind of my purpose of doing these TikToks is to drum up a little business. But you are welcome to come in here. When you get in, please read the rules, react to them, pick a role, whether you're a student or a parent. And then all these other channels will pop up for you. And when you go to the public sessions, you can see I'm live from 8 to 9 on Mondays. And then if you ever want, you can post questions in here from your math topics and what you need help with. And I'll actually pull these up, do them for you, and tag you in them if you want. Or you can just look for them on my TikTok, and I'll answer those and post those videos as well. I'm a huge fan of bands, so I post a lot of live music. That's my boy's axolotl, and I love cooking. I don't post as much. I need to post more food. I should post my Thanksgiving. What's it called? If you go into your quickest way is go into my Twitch, and go to my profile, and you'll see this Discord link right here, and that will get you straight to the Discord channel for the tutoring. It's just going to be the fastest way to get it. And then that will hook you up once again with my Discord channel. You can rummage around wherever you want, look through everything. I posted some challenge problems, but I don't do it enough. Hey, what's going on, Cantor? My man. All right. It was covered. I'm so sorry. Let me turn that back. Pull this back up. Right here. Copy. Oh, you know what? Because I am that good. Boom! I need a moderator. You can copy and paste it into the chat. My bad. Still learning. Still getting these things. So, hey, what can I say? We do what we can. All right. So, yeah. Definitely don't need to save that. But yeah, please feel free in the Discord channel, especially in the public lessons. You might not see private lessons. Those are for people that are legit paying for tutoring sessions with me. You'll see my schedule here, but in the questions tab, feel free. And let me show you just a little bit, but oops. I don't want to do that. You can see they post questions all the time and we work through them. These are a lot of calc-based questions. I've got a calc when I'm tutoring. But yeah, throw questions in here and I will be more than happy to post some answers for you. All right, with all that, no further ado, I am going to bounce so that I can start making some YouTube videos for my students so that they can get their homework done. But once again, if you need anything, pop in the Discord, ask me some questions. Like my goal for this really, I'm trying to do a side hustle with tutoring, but I just want people to feel more comfortable with math, and be more more positive about the outlook of their math and their math skills. It just takes practice. Kat, I can't thank you enough. Awesome. Hey, I'm glad you did. I'm glad you came in. Please feel free to come back anytime. Mondays, I'll definitely be on at 8 o'clock. And good luck with your test tomorrow. I hope it goes well. Even drop me a note in Discord if you join it. Like, let me know how it goes, man. Or woman, sorry, please. Tuesdays. What about Tuesdays? Going live? You want me to do live shows every day for free? What's going on? I know I've got a private session on Wednesday and Thursday. And I'll try tomorrow, but I don't know. My wife, I got to also hang out with my wife. I got to stay married, So if I can, I will definitely. Are you doing it live tomorrow? Yeah, I don't know. I will try my best. How about that, Kat? I will do my best. You know what? I will tell you what would be the most beneficial really for me. Drop a question in here. And I'll go live at least for like 15, 20 minutes to answer your question tomorrow at some point. Probably be like 7 or 8 o'clock. So I would do that. So how about that? You put me a question, like take a picture with your phone or chop it up with your phone, post it in here, and then tomorrow for like 15, 20 minutes, I'll pop on and go live and answer your question. All right? All right. Well, have a blessed night. Thank you for everybody that stopped by, and thank you for all the love today. I appreciate it.